On a cold November evening in 1895, inside a dim laboratory in Würzburg, a quiet, methodical scientist noticed something impossible. A faint glow from across the room. There was no flame, no candle, no sunlight. Yet something unseen was passing through solid matter and lighting up the darkness. That moment would change medicine, science, war, and the very way humanity understands the body forever. The man's name was Wilhelm Conrad Röntgen, and what he had just discovered would become known as X-rays. The accidental discovery Röntgen was not trying to revolutionize medicine. He was experimenting with cathode rays, streams of electrons, in a vacuum tube covered with black cardboard. One evening, he noticed that a nearby screen coated with barium platinocyanide began to glow whenever the tube was active, even though it was completely covered. Something invisible was escaping, something powerful. He called it X-radiation, the X standing for unknown. Curious and cautious, he began experimenting further. He placed different objects between the tube and the screen: books, wood, metal. Most materials allowed the rays to pass through, but bones cast shadows. In one of the most iconic moments in scientific history, Röntgen asked his wife, Anna Bertha Röntgen, to place her hand in front of the apparatus. The result was the first X-ray image ever taken, a haunting picture of her skeletal hand, with her wedding ring floating like a ghost. She reportedly said, "I have seen my death." Why was X-ray invented? Interestingly, X-rays were not invented with a specific purpose in mind. They were discovered, but once the discovery was made, its purpose became immediately clear. For the first time in human history, doctors could look inside the human body without cutting it open, detect broken bones instantly, locate bullets and foreign objects, diagnose internal diseases. Before this, medical diagnosis relied on external symptoms, pain descriptions, guesswork, risky, exploratory surgery. X-rays eliminated the need for blind procedures. They turned medicine into something closer to science and less like educated guessing. What did the first X-ray machine look like? The first X-ray machine was nothing like the modern devices we see today. It was crude, dangerous, and experimental. It consisted of a Crookes tube, a glass vacuum tube, high-voltage electrical power, a fluorescent screen. No shielding at all, the machine emitted radiation in all directions. There was no understanding of radiation safety. Doctors and scientists often exposed themselves repeatedly, leading to burns, injuries, and even death. Early X-ray pioneers unknowingly sacrificed their health. How is an X-ray machine made? Modern X-ray machines are far more advanced and safe. They typically include X-ray tube contains a cathode, electron source, and anode, target. High-voltage generator accelerates electrons at high speed. Control panel adjusts intensity. An exposure time collimator focuses the beam detector or film, captures the image lead shielding, protects patients and operators. How it works. Electrons are accelerated toward a metal target. When they hit, energy is released as X-rays. X-rays pass through the body. Dense materials, like bones, absorb more radiation. The remaining rays hit a detector, creating an image. Before X-rays, medicine in the dark. Before X-rays, doctors relied on palpation, touching and feeling, listening, stethoscope. Patient symptoms. Exploratory surgery. If someone had a broken bone, doctors guessed. If a bullet was lodged inside a soldier, surgeons had to cut open the body and search blindly. Many patients died, not from the injury, but from the treatment. The arrival of X-rays during conflicts like the World War I saved countless lives. Doctors could locate shrapnel instantly. Treatment became faster, safer, more precise. X-rays in medicine today. Today, X-rays are a foundation of modern healthcare. They are used in 1. Diagnostic imaging bone fractures, lung infections, like pneumonia, dental problems. CT scans a more advanced form of X-ray imaging that creates 3D images of the body. Cancer. Treatment radiation therapy uses controlled X-rays to kill cancer cells. Airport security scanning luggage and detecting threats. Industrial use checking metal structures and pipelines for defects. The most powerful X-ray machines. Today, some of the most powerful X-ray systems are not in hospitals, but in research facilities. One of the most advanced is found in the SLAC National Accelerator Laboratory in the United States. Their machine, known as the Linac Coherent Light Source, LCLS, produces ultra-powerful X-ray pulses, special features, can image atoms and molecules in motion, captures chemical reactions in real time, used in cutting-edge physics and biology research. Another powerful facility is in the United Kingdom, the Diamond Light Source, which supports advanced medical and scientific studies. How X-rays change civilization. The impact of X-rays goes far beyond medicine. They transformed. Science-enabled atomic-level research, helped discover DNA structure, war-improved battlefield surgery, saved soldiers. Lives industry improved safety and quality control. Daily life, safer travel. Better healthcare, it marked the beginning of non-invasive technology, a concept that defines modern innovation. Positive and negative effects. Positive effects. Early disease. Detection reduced surgical risks. Faster diagnosis, improved survival rates. Negative effects, radiation exposure risks, cancer risk from overuse. Early scientists suffered severe injuries. Today, strict safety protocols minimize these risks. The future of X-ray technology. The future of X-rays is incredibly promising. We are moving toward AI-powered diagnostics, ultra-low radiation imaging, real-time internal imaging, portable X-ray devices. Nanotechnology-based scanning. One day, doctors may be able to scan the entire body instantly, with zero harm. The light that revealed the invisible. What began as a faint glow in a dark room became one of the most powerful tools in human history. X-rays gave us the ability to see what was once hidden. They turned mystery into knowledge, fear into understanding, and guesswork into precision. From a single experiment in Germany to life-saving machines across the world, from the United States to the United Kingdom, the journey of X-rays is a testament to human curiosity. Röntgen didn't set out to change the world, but he did. And every time a doctor looks at an X-ray image today, they are seeing not just bones, but the invisible light that changed humanity forever. The story of X-rays is not just about a machine, it is about a moment of curiosity that unlocked a new dimension of reality, a reminder that sometimes the greatest discoveries are not planned, they are noticed, and in that noticing, the world changes.